Now we have to find the Laplace transform of cosine wave. Laplace transform of cosine wave. So for that we have to consider a signal that is x of t. So that is, we have to obtain the Laplace transform of x of t a cos of omega t ut. We write here, consider signal x of t is equal to a cos of omega t u of t. Equation number 25. So from the definition of Laplace transform, we can write xf is equal to integration minus infinity to infinity x of t e raised to minus st dt, e raised to minus st dt. So we can write x of f is equal to minus infinity to infinity a cos of omega t u of t e raised to minus st dt. You can also write xf is, it is 0 to infinity a cos of omega t e raised to minus st dt. This is equation number 26. So it is, now we have the trigonometric identity. We write here, we have trigonometric identity. So cos of theta is equal to e raised to j theta plus e raised to minus j theta divided by 2. Therefore we can write x of s is equal to 0 to infinity a e raised to j omega t plus e raised to minus j omega t divided by 2 e raised to minus st dt. So we can write this equation as xs. We can simplify it. A is constant outside the integration, 2 is constant outside integration. It is 0 to infinity e raised to j omega t into e raised to minus st, okay, plus integration 0 to infinity e raised to minus j omega t e raised to minus st dt. So this is equation number 27. Now we have standard Laplace transform pair. We write here we have standard Laplace transform pair. So it is e raised to at u of t. Its Laplace transform is what? It is 1 by s minus a. And ROC for this is sigma greater than a. So we can write above equation Laplace of e raised to j omega t u of t. It is 1 by s minus j omega, where ROC is sigma greater than j omega. So next is similarly we can write similarly we have e raised to minus at u of t. Its Laplace is 1 by s plus a, and here ROC is sigma greater than minus a. Therefore Laplace of e raised to minus j omega t u of t, it is 1 by s plus j omega, and its ROC is sigma greater than minus j omega. So now we put these values in equation 27. We write here put these values in equation 27. So x of s is a by 2 1 by s minus j omega plus 1 by s plus j omega. So it is x of s is equal to a by 2. We solve it cross multiplication. So it is s square plus omega square. S get cancelled. It will be a 2 get cancelled. A s divided by s square plus omega square. Now we have to draw the diagram for the ROC. So here the first term ROC is sigma greater than j omega. We write here. So we write here ROC is for the first term ROC is sigma greater than j omega. That means sigma greater than 0 plus j omega. So considering only real part, we are considering only real part. So ROC is sigma greater than 0. Now we write for the second term ROC is sigma greater than minus j omega, that is sigma greater than 0 minus j omega. So considering only real part, so ROC is sigma greater than 0. Now we have to draw so combined ROC, we write here combined ROC is sigma greater than 0. Now diagram for this is same as that of the previous, that is it is sigma, it is j omega, sigma greater than 0, so it will be like this. Okay, this is point of origin. So this is the standard Laplace transform. Here we write here Laplace transform A cos of omega t u of t. Its Laplace transform is A s by s square plus omega square ROC sigma greater than 0. So in this way we can obtain the Laplace transform of cosine wave. Now next is Laplace transform of damped sine wave. Laplace transform of damped sine wave. That is we have to obtain Laplace transform of x of t is equal to e raised to minus at sine omega t u of t. Now consider damped wave sine wave, which is given by x of t is equal to e raised to minus at sine of omega t u of t. This is equation number 28. Okay. Now next, from the definition of Laplace transform, we write here from definition of Laplace transform. So we have xs is equal to integration minus infinity to infinity x of t e raised to minus st dt. Okay, so we can write this equation as it is minus infinity to infinity. What is x of t? This equation. So we write e raised to minus at sine omega t u of t into this one, into this term into e raised to minus st dt. This is equation number 29. So, but we have the equation for sin omega t, trigonometry, but we have sin of omega t is equal to e raised to j omega t minus e raised to minus j omega t divided by 2j. So we can also write x of s is equal to 0 to infinity e raised to minus at e raised to j omega t e raised to minus j omega t divided by 2j into e raised to minus st dt as it is. So we can write this equation x of s is equal to 1 by 2j is constant outside the integration, it is 0 to infinity e raised to minus at e raised to j omega t, or we can say e raised to minus a minus j omega into t. Okay, we take common e raised to by 2j 0 to infinity, we can write e raised to minus of a minus j omega t minus e raised to minus of a plus j omega t, okay, into e raised to minus st dt. So now we can write xs is equal to 1 by 2j 0 to infinity e raised to minus of a minus j omega into t into e raised to minus st dt minus 0 to infinity e raised to minus a plus j omega into e raised to minus st dt. This is equation number 30. We just multiply this term inside the bracket. Now we have a standard Laplace transform pair, so we will use it. We write here. Now we have standard Laplace transform pair, standard Laplace transform pair. So we have equation e raised to minus at, its Laplace is 1 by s plus a. So ROC for this sigma greater than a. Therefore Laplace of e raised to minus of a minus j omega to t equal to 1 by s plus a minus j omega, and ROC is sigma greater than minus of a minus j omega. And what is Laplace transform e raised to minus a plus j omega into t, its Laplace is 1 by s plus a plus j omega. So its ROC is sigma greater than minus of a plus j omega. Now we put this equation, put these values in above equation. So equation becomes x of s is equal to 1 by 2j into 1 by s plus a minus j omega minus 1 by s plus a plus j omega. So we can also write this as 1 by 2j into 2j omega divided by s plus a square plus omega square. Or we can write j get cancelled, 2 get cancelled, so it becomes omega divided by s plus a square plus omega square. So this is the Laplace value. Now we have to draw the ROC for this. So now we draw ROC. So for the first term, write here, for the first term ROC is sigma greater than minus of A minus j omega, that is sigma greater than minus of A plus j omega. Thus we can write it as sigma greater than minus A. And for the second term, ROC is sigma greater than minus of A plus j omega, that is sigma greater than minus of A minus j omega. So we can write it as sigma greater than also minus A. So what is combined ROC? Now the combined ROC is sigma greater than minus A. So we can draw diagram or ROC for this, as this is sigma, it is j omega. Now your pole is at minus A. So sigma greater than minus A. So this is region of convergence, that ROC. And we can write Laplace transform e raised to minus at sine of omega t u of t. Its Laplace transform is omega divided by s plus a square plus omega square, and here ROC is sigma greater than minus A. In this way we can find the Laplace transform of damped sine wave. Now next is Laplace transform of damped cosine wave. So next is we have to find Laplace transform of damped cosine wave. So consider damped cosine wave as x of t e raised to minus at cos of omega t u of t. Equation number 31. Now from the definition of Laplace transform, from the definition of Laplace transform. Xs is minus infinity to infinity x of t e raised to minus st dt. So x of s is minus infinity to infinity e raised to minus at cos of omega t u of t e raised to minus st dt. This is equation number 32. Now we have trigonometric equation. We have cos of omega t is equal to e raised to j omega t plus e raised to minus j omega t divided by 2. So we can write this equation as x of s is equal to 0 to infinity e raised to minus at e raised to j omega t plus e raised to minus omega t divided by 2 into e raised to minus st dt. Now 1 by 2 is constant outside the integration 0 to infinity e raised to minus of a minus j omega t is common outside the bracket into e raised to minus st dt plus 0 to infinity e raised to minus of a plus j omega into t e raised to minus st dt. This is equation number 33. Now we have standard Laplace transform pair. So we have e raised to minus at its Laplace transform is s1 by s plus a, and here sigma greater than minus a. So therefore we can write Laplace transform e raised to minus of a minus j omega into t. Its Laplace transform is 1 by s plus a minus j omega. Here ROC 1 greater than minus of a minus j omega. Similarly, we can write the Laplace transform of e raised to minus of a plus j omega to t. So its Laplace transform is 1 divided by s plus a plus j omega, and ROC a j omega. Now we put these values in equation number above equation, that is equation number 33. So equation 33 becomes, equation 33 is x of s is equal to 1 by 2 into 1 by s plus a minus j omega plus 1 by s into a plus j omega. that is 1 by 2 into 2 into s plus a divided by s plus a square plus omega square. So 2 get cancelled. It is s plus a square plus omega square. Now we have to write the ROC for this. So ROC is for first term, the ROC is sigma greater than minus of a minus j omega, that is sigma greater than minus a plus j omega. So ROC is, therefore ROC is sigma greater than minus a. As we are considering only the real part, so sigma greater than minus a. Now next is for the second term. For second term, ROC is sigma greater than minus of a plus j omega, that is sigma greater than minus a minus j omega. Therefore we are considering only the real term, so sigma ROC is sigma greater than minus a. Okay. So combined ROC is sigma greater than minus a. Now we will draw a diagram for this. It is same as that of the previous diagram. It is sigma greater than minus a. Here is the pole minus a. So it is sigma greater than minus a. So this is ROC, and e raised to minus a t sine of omega t e raised to minus a t cos of omega t u of t, its Laplace transform is s plus a divided by s plus a square plus omega square, and its ROC is sigma greater than minus a. So in this way we can find the Laplace transform of different functions. That is for sine wave, for cosine wave, damped sine wave, damped cosine wave. In the next lecture we will see the properties of Laplace transform, its proof,